Okay, so we're going to start off by learning about standard position for angles. Standard position is when the vertex of an angle is at the origin. So we're in a coordinate plane now, okay, with an x and a y axis. And the initial side of the angle is on the positive x-axis. All right, so let me show you what that looks like. You know, I just mentioned coordinate plane. So x-axis or y-axis, x-axis. The vertex of our angle is at the origin. We don't often draw in that point, but I'm just drawing it in right now so we can see it clearly. The initial side of your angle is on the x-axis. So this right here is the initial side of the angle. You can think of this as this is where the angle starts. So angles have, two sides. So the terminal side is where your angle ends. So let's say our angle goes, let's say to here. What you're going to notice is when we draw angles, you're going to include kind of a little arrow right here to tell us the direction of the angle. Positive angles from the initial side are going to go up in a counterclockwise direction. Negative angles would go down in a clockwise direction. So you do want to, if you draw an angle, you have to include this part so we can tell if it's a positive or a negative angle measure. Okay, so let's say our angle ends right there. That would be the terminal side of the angle. And I kind of think of that as where the angle ends. Okay, so that is standard position. Initial side, terminal side, we can just reference the picture. We just kind of drew that in. So now let's look at an angle we're given. What is the measure of the angle shown? So we can see an angle in standard position. We have our initial side. We can see our angle is positive because it's going up, and this is the terminal side. They also gave us a coordinate right here. This point is on the terminal side of our angle, and that ordered pair is -4 and that for the x and 4√3 for the y. So in order to find information on these, we are going to create a triangle. We're going to create a right triangle. So from that ordered pair, -4, 4√3, if we drop a line down to create a triangle, we have to go straight down. It's always to the x-axis. Make a note, always connect to the x-axis. There's a couple other things where we connect to the x-axis. It's always, 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 always to the x-axis. Have I made my point? Please, please, please. If you're going to draw in a triangle, you connect it to the x-axis. That gives us our right angle. So now we have a right triangle. Well, we like right triangles. I'll go ahead and draw the right triangle over here. We know some things about right triangles. If I look at, because I know that that's a -4, 4√3, that means that we went -4 to the left and we went up 4√3 for the y. We went to the left and up to plot that point. So that gives me two sides of a right triangle. Even though that is a -4, I'm just going to think in terms of distance right now. This is a 4. This is a 4√3. So what we notice and want to just start to recognize in our right triangle, not the hypotenuse, but the two sides, the smaller side, if we take that and multiply it by root 3, we get the bigger side. This is a 30, 60, 90 triangle. The smaller side is one measurement. The bigger side is always the smaller side times root 3. So if we recognize that relationship, then we know this is a 30, 60, 90 triangle. The smaller side will be opposite the 30-degree angle, and the bigger side, the 4 times the root 3, is bigger than the other side 4, is a 60-degree. So just by getting a couple sides of our triangle, we recognize or can figure out, can conclude that we have a 60-degree angle right there. So if we go back to the picture, what does that mean for us? That means that the angle inside the triangle right here is 60 degrees. Well, how does that help us out? If you remember from geometry, if I were to draw an angle here, and if I kept going to all the way to the other side of the x-axis, that is 180 degrees. So if this part of our angle is 60 degrees, what must that be so that they will add up to 180 degrees? And we can do the math. We can say, oh, well, if I take the total 180, subtract the 60, or sometimes we can just think it through. That is going to be a 120-degree angle. So the question, what is the measure of the angle shown? This is the angle over here, this side, but we were able to connect to the x-axis and work with a right triangle. So what is the measure of the angle shown? 120 degrees. All right, so last idea for this video is something called a coterminal angle. So coterminal angles, let's define that. Those are angles that share a terminal side. They are coterminal. So it kind of makes sense. They share a terminal side. So what that looks like, let me just show you a quick picture. Let's say that I have a positive angle measure of, I don't know, maybe 45 degrees. That's a 45-degree angle. So a coterminal angle would be any other angle that lands in that same spot. Well, what if I drew a negative angle? If I went down all the way around and landed right there, it would share a terminal side. So that angle, if I go down and land there, is a negative 315-degree angle. So those two would be coterminal. So that's what it looks like. Two angles that share a terminal side of the angle. All right, so to find coterminal angles, because sometimes they just say find coterminal angles, you can just add or subtract multiples of 360 to find coterminal angles. So let's take a look at an example with a different angle measure. Let's find some coterminal angles with 120 degrees. So we just take 120 and add 360 degrees. That gets us to 480. If we look at our angle up here, there's 120 degrees. If you go around one full rotation, you land in the same spot, that gets you to 480. Well, you could go around another rotation and land in the same spot. So every time you add 360, you are going one full rotation around and getting a bigger angle. So we can add 360 and get 840 degrees. There's another coterminal angles. Those are positive, so those are positive coterminal angles. You can find negative coterminal angles by subtracting 360. So if you take 120 and you subtract 360, we get negative 240 degrees. Negative 240 degrees and 120 would share a terminal side. They would land in the same spot. You could subtract 360 degrees again and get negative 480 degrees. That's another coterminal angle. So all of these angles found by adding or subtracting multiples of 360 are coterminal angles.